Kimberto presents, as part of a project for College of Marin Geology 249, the Marine Terraces of Santa Cruz, California. Marine terraces, also known as raised platforms, are planar landforms of marine origin which are formed by a combination of erosional processes, the rising and falling of sea levels, and tectonic uplift. This photo, taken just north of Santa Cruz, California, shows a typical section of coast from this region, including steep, jagged cliffs, a wave-cut platform on the shore, and an expanse of marine terrace overlooking the Pacific Ocean. This diagram outlines marine terrace formation. At number 1, waves cut into the land, forming a new terrace. Number 2 shows the uplift of the continental land in relation to sea level. Number 3 indicates an uplifted older marine terrace, and number 4 shows an even older marine terrace. You can see how marine terraces form in a stair-step fashion. This animation shows how marine terraces are formed. Notice how the rise and fall of sea level, combined with the uplift of the land, forms marine terraces over time. This illustration of a series of marine terraces shows the stair-step landform created by successive marine terraces. The modern shore platform, item number 2, will eventually rise above sea level, creating the next marine terrace. Note the terraces, which are further inland, are higher in altitude and older as their distance increases away from the shoreline. This diagram shows more details of a typical marine terrace. Looking at this diagram, where would you dig to find fossils, and where would you expect the older fossils to be? Remember, older terraces are further from the shore. Wilder Ranch State Park, just north of Santa Cruz, is an excellent location to actually hike across well-defined marine terraces. Remember, the age of the terraces increases with distance from the modern shoreline, as indicated on the photo on the right. Also note the location of Highway 1 across the most recent terrace. Here we are looking across the most recent marine terrace at Wilder Ranch State Park from Highway 1. The younger terraces are the most nutrient-rich and fertile and are often used for agriculture. Brussels sprouts, strawberries, and artichokes, and many other crops are produced on this lower marine terrace near Santa Cruz. The soil characteristics differ from terrace to terrace. The older the terrace, the less fertile and more depleted their soils are. This changes the types of plant growth we find on different age terraces. Remember, most agriculture is on the lowest and most fertile terrace. Some older terraces with depleted soils over hardpan surfaces host pygmy forests. This is more common in Northern California as opposed to Central California. Here we see the relationships between marine terrace formation, time, and relative sea levels. The graph on the lower right shows relative sea levels over time. Notice how sea levels reach maximums at approximately 100,000-year intervals, as indicated by the red arrows. The maximum levels are when the new marine terraces are carved out of the uplifting shoreline. As sea levels drop and the continental land continues to rise, the stair-step pattern of marine terraces develops on land over hundreds of thousands of years. A phenomenon known as the Milankovitch cycles accounts for the cyclical formation of marine terraces. There are three Milankovitch cycles as illustrated here. On the far left, precession, or wobble of the Earth on its axis, is shown. This varies in a 26,000-year cycle. In the center, we can see how Earth's obliquity, or axial tilt, changes over a 41,000-year cycle. On the far right, Earth's eccentricity is shown. Eccentricity is the deviation of a planet's orbit from circularity. Earth's eccentricity varies over about a 100,000-year cycle. These all combine to change the amount of solar radiation which reaches Earth at points in these cycles. Serbian scientist Milankovitch thought that the obliquity, the center illustration, had the greatest effect on Earth's climate. But over the last million years or so, eccentricity seems to be the dominant factor. There is still much we don't know about these cycles. This is how Milankovitch cycles influence marine terrace formation. First, decreased sunlight to Earth, as predicted by Milankovitch cycles, results in a decrease in insolation, which is solar radiation. Less insolation results in less melting of glaciers, especially in the northern hemisphere. This results in more ice, which also has a high albedo, that is, a reflectivity, which further decreases insolation. As glaciers form, water from the sea is sequestered as ice, causing sea levels to drop. The land continuously uplifted by tectonics rises the newly formed wave-cut platforms above sea levels, which then become new marine terraces. Here's a diagram illustrating the geology of the marine terraces near Santa Cruz. The shoreline is on the far left, and next to it on the right is the most recent marine terrace, the Santa Cruz Terrace. Note the location of Highway 1 on this terrace, and also note the underlying Santa Cruz mudstone. Further to the right, you can see an older sea cliff, and above that sea cliff is the older Western Terrace, which is at the highest altitude on this image. Remember, there are more terraces even further inland. This map shows the marine terraces from the city of Santa Cruz on the far right northward to Point Año Nuevo on the far left. The key on the upper right portion shows the marine terraces in this area. The youngest marine terrace, the Santa Cruz Marine Terrace, borders the Pacific Ocean all along this portion of the coast. Highway 1 is located on the Santa Cruz Marine Terrace, and much of the city of Santa Cruz is built on this same terrace. The Western Marine Terrace is just to the east of Highway 1. The stars on the map indicate the Coast Dairy State Beach and Wilder Ranch State Park, where many of the photographs in this presentation were taken. Here is a final view of the coast looking across several marine terraces towards the south, towards the city of Santa Cruz. If you enjoyed this video, please take a look at some of my other presentations. Thanks for watching.